This project is entitled Long-Term Hydrological Dynamics of Canada's Largest Watershed, the Mackenzie River Basin. Next slide, please. The Mackenzie River Basin is one of the world's largest and most important freshwater ecosystems. It is located in northwestern Canada, where climate change is disproportionately affecting sensitive subarctic ecosystems. This project seeks to evaluate how climate change will affect water quantity in the Mackenzie River Basin. To achieve this goal, this project will examine long-term trends and cycles to develop predictive ecohydrological models. Next slide, please. This project will benefit from contributions from researchers across the Geological Survey of Canada, from the Government of the Northwest Territories, from Canadian and international universities, and from the Gwich'in Renewable Resources Board and Gwich'in Tribal Council, Department of Cultural Heritage. This project seeks to support training of the next generation of geoscientists and environmental scientists. Next slide, please. This project is jointly funded by the Geological Survey of Canada and ArcticNet under project number 51. Progress to date includes initiation of traditional knowledge studies. Our approach will focus on synthesis of previously documented traditional knowledge related to water levels in the Gwich'in settlement area of the Mackenzie River Basin. This approach builds on an existing body of work to prevent interview fatigue. Next slide, please. Other progress to date includes preparation of existing peatland monoliths collected in support of this project for various analyses. These analyses include organic matter characterization, determination of the concentration of elements and organic contaminants, radiometric dating, and micropaleontological analyses. Our goal is to reconstruct depth to water table, fire and vegetation history, chemical change, and hydrological change. We will relate our findings to synoptic scale climate patterns, such as the Pacific Decadal Oscillation, that we hypothesize drive water quantity change in the Mackenzie River Basin. Next slide, please. Some highlights to date are that our project team has shown that climate warming results in increased production of organic matter in subarctic lakes. Increased organic matter mediates redox conditions, leading to the release of elements previously stored in sediments to overlying surface waters. Climate change thus needs to be considered in environmental assessment, remediation strategies, and land use planning. We also show that testate lobose amoeba, shelled benthic protists, respond to changes in the geochemistry of the lake sediments in which they live. These are sensitive bioindicators of arsenic in subarctic lakes. They can be used to reconstruct the concentration of this redox-sensitive element in sedimentary profiles. Next slide, please. This slide lists some of the research outputs for further reading. Next slide, please. I would welcome any comments or questions, and my contact information is shown in this slide here. Thank you for your attention.